In 1983, aerospace executive Norman Augustine formulated a mathematical law that the global defense industry ignored for 4 decades. He calculated that the unit cost of military aircraft was growing exponentially, predicting that by the mid-21st century, the entire United States defense budget would be able to afford exactly one single airplane. Today, that mathematical absurdity has become operational reality. Modern defense procurement has fallen into a catastrophic engineering trap. We have spent hundreds of billions of dollars optimizing single exquisite platforms, $300 million fighters, $4 million interceptor missiles, and $26 billion aircraft carrier strike grids. Yet, on the modern battlefield, these ultra-complex weapon systems are facing a lethal asymmetric crisis that has nothing to do with technological sophistication. It is a failure of manufacturing scale, supply chain physics, and the brutal mathematics. Welcome back to BlackBox UAV. Today we are opening the black box on the defense procurement trap. Why the era of exquisite mega weapons is over, and how $500 autonomous systems broke modern military economics. Consider the pinnacle of 20th century force projection, the USS Gerald R. Ford. The ship itself cost $13.3 billion to construct. Add $4.7 billion in research and development, and 85 carrier-based aircraft, and you have over $26 billion of national capital concentrated into a single point on the ocean. Naval planners designed this hull to survive direct hits from heavy anti-ship cruise missiles and torpedoes. However, modern autonomous warfare does not need to sink the ship. It only needs to achieve a mission kill. The flight deck relies entirely on the Electromagnetic Aircraft Launch System, or EMALS. Unlike legacy steam pistons, EMALS linear motor tracks require microscopic millimeter alignments across hundreds of meters of deck plating. Simultaneously, the ship's primary eyes, the active phased array radar faces on the island superstructure, are completely exposed. A fragmentation warhead detonating 50 meters away shreds the delicate gallium nitride transmit-receive modules. The ship remains afloat, but it is rendered instantly blind and incapable of launching combat aircraft. A $26 billion sovereign asset is forced to withdraw for an 18-month dry dock overhaul. The asymmetry becomes even more severe when analyzing integrated air and missile defense networks. The primary shield protecting modern command nodes is the Patriot PAC-3 MSE interceptor. It is an engineering masterpiece, carrying hit-to-kill kinetic warheads, attitude control thrusters, and active K-band radar seekers. It costs roughly $5.2 million per missile. The bottleneck is not just the price tag. It is the industrial manufacturing throughput. Lockheed Martin produces roughly 600 PAC-3 MSE missiles per year for the entire global supply chain. The production cycle is constrained by chemical curing times for specialized solid rocket propellants and precision micro-machining of seeker gimbals. Now, look at the offensive math. A Delta Wing loitering munition costs $20,000 and can be mass-produced in commercial automotive facilities at rates exceeding thousands of units per month. To counter a saturation attack of 100 drones, air defense doctrine dictates firing 2 interceptors per target to ensure a high probability of kill. In a single 6-hour engagement, the defending force burns through 200 PAC-3 missiles. That single engagement costs over $1 billion and exhausts 1/3 of the total annual global production of the free world's primary anti-air weapon. You cannot sustain an industrial war when your weapons take 2 years to manufacture and 6 seconds to burn. This industrial reality forced the Pentagon to hit the emergency brake on its crown jewel program, the Next Generation Air Dominance Fighter. Initial design estimates for the NGAD 6th Generation manned platform pushed unit costs past $300 million per aircraft. At that price, losing 5 aircraft in a contested air defense zone represents an unrecoverable strategic disaster. Furthermore, fifth-generation platforms, like the F-35, currently suffer from mission-capable rates hovering near 55% due to complex stealth skin maintenance and engine thermal degradation. Air forces cannot afford an armada of hangar queens. This realization triggered the sudden doctrinal pivot toward collaborative combat aircraft, or CCA. Instead of building a handful of irreplaceable, exquisite platforms, aerospace architecture is shifting towards software-defined, attritable wingmen, costing $15 to $20 million each. These autonomous drones act as forward sensor nodes, electronic warfare screens, and missile trucks, absorbing the enemy's initial defensive salvos while preserving the human command structure. The century of heavy industrial military dominance is officially over. The future of aerospace defense belongs to the factories that can iterate code in hours rather than decades, and produce mass at a cost that breaks the adversary's interceptor economics. Victory will no longer be determined by who builds the most advanced $20 billion platform. It will belong to whoever can deploy hundreds of thousands of low-cost, software-upgradable autonomous nodes that make expensive weapons irrelevant. The procurement trap has closed. The only way out is through the unyielding math of attritable mass. Subscribe to BlackBox UAV for deep, uncompromising aerospace engineering analysis. Stay secure, and I will see you in the next breakdown.